We are going to check the boxes that are the forces present in each situation. Okay? Some of these situations, if you read more into it than I am originally intending, we can get some more forces. So I want to be very specific as we talk about each of these situations. Okay? So for this first one, we have a box suspended from the ceiling by a cable. So the hints we have here are, we know that it is, go to your markup. So we know it is suspended, and it also says by a cable. Okay, so those are both big hints that we have FT. We are also on planet Earth, so we have FG. This next one is a ball flies through the air. And again, through the air is the big hint here. Okay, so we are on planet Earth, so we're FG. But over here, we also have air resistance because we are moving through the air. Okay, and if at any point you're I'm going too fast or something, please just speak up. Okay, so this next one. Box rests, and we're told it's resting on incline. So on incline means that there's some sort of a ramp, but it's not moving, it's resting. Okay, those are the real keywords there. So we are on planet Earth, so we have FG. We have FN because we are resting on a surface. And we have a friction force that is holding us in place, FFS, just to specify that. For this next one, we also have a book at rest, but for this one, it's just on a table. And do we see how the surface is parallel with the ground? Because the surface is parallel with the ground, we just have FG and FN. There's no risk of this rolling off the desk. It's just going to sit there. Okay. For this next one, again, we have a person falling. And if we're looking at this, through the air is the real kind of cue here. So through the air. Okay. So we are on planet Earth. And we also have air resistance. Okay, so for this next one, this is where we need to really think about what is happening with the actual scenario. Okay, so I just kind of want to type some stuff in, just so that we're being super, super clear here. So a ball is rolling up the hill, right? There is no mention of someone pushing. There's no mention of someone pushing the ball. Oops. Just shrink this down. So I'm going to shrink this text just a little bit so it fits a little bit better. There's no mention of someone pushing the ball, so there's no current contact. We need contact in order to have a push force. Okay, so there's no push force here. So this means no push force. There's also no mention of friction. Oops. So we have to assume that friction is happening. So a lot of times I feel like you can kind of assume, oh, if something's not mentioned, we are assuming that it is not happening, okay? But with physics, with this stuff, we are going to either be told that there is a frictionless surface, or we're going to be not mentioned anything, okay? So that's why if it's not mentioned, you can assume that the surface has friction, okay? We are always assuming the surface has friction. So we have gravity because we're on planet Earth, normal force because the ball is resting on an object. Even though it is in motion, the mass of the ball is still being supported by the hill. And we also have a friction force. We have FFK. Okay. And again, we do not have a push force because there is no contact. Just to make sure that is very, very clear. No push force because there is no contact. Okay, so here's this next one. So we have a person who is playing tug of war with small children. Okay? This is where we start to get into a little bit of gray area, right? You can start to assume a lot of things about this specific situation. The one thing that I can say is that when we have situations that you can read a lot into, we tend to use those situations for the packet to kind of expand your thinking, get you thinking about it. And honestly, if you can start to see different forces in this, depending on how the scenario is being told, then I kind of feel like you understand what's happening here a little better, okay? You will never have a gray area scenario on a quiz. Okay, so this is a very gray area scenario. Okay. Okay, so we definitely have gravity force, and we are looking at, specifically with this, we are looking at this person. Okay, this is the person that we're drawing the free body diagram here of. So we're definitely on planet Earth. We definitely have normal force. The guy is just standing there, okay? We definitely have pull force because he is, so he is pulling the children. The children are also pulling him, okay? He is not in motion. So we have FFS. And this is one where I feel like you do kind of have to have FFS, but again, depending on how you are talking about the situation, it's one of those that and also like tension force for this one also, it depends on how you are describing the situation, really. Okay. So for this next one, box is pulled by girl, and for this we are assuming movement. So if we're assuming movement, so we have gravity force, we have normal force, we also have push force, okay, because it's being pulled, box is being pulled, box has that action occurring on it. And then since we have movement, we also have FFK. Okay, and for this next one, I want us to kind of look here. Do we see how he's standing on the surface? Okay, so we have gravity force because we're on planet Earth, normal force, okay? We definitely also have tension force, which is this final box, tension force. We have tension force because he's being suspended from this cord. I would also say that we have FFS. If you're looking again at the foot, do we see how with the foot, like the foot is kind of resting on that surface, but it probably also is getting some traction on that surface?